Okay, I'm gonna continue doing those matrix equations because I think you still confused with some of those concepts, and I will also do the one that was I didn't finish in class, so I can show you how to actually do it. But before that, let me share some information with you because I think you guys are not checking anything in this Google Classroom. To be honest with you, you have to check. That's the reason I put this stuff here. You have to check. Um, if you what is that stuff? Let's see. So I put here this topic. It says matrix properties and examples. So you should click on here, and if you click on these links, let's start with this one because this is the latest one I think that I post. Um, you have to read this stuff, right? I mean, if you don't read this, how are you supposed to do? How are you supposed to do good on the test? I mean, I cannot do everything all the time for you. You have to practice, especially these dimensions that they have to be satisfied. Like you, by now you should know this. I think most of you are comfortable with this, but just in case, just practice or read these slides. Here you have the properties of the matrices, which will help you to solve the equations. If you don't practice this, then I don't know, you will have a hard time. Everything is explained here. Um, they explain to you all these concepts. Uh, Here they talk about the why matrix multiplication is not commutative in general. So that's the concept. Uh, what else? I think there's, yeah, this is the most important thing that you need to remember, right? These properties, A transpose is just give you back the original matrix A. These properties you need to practice, right? I mean, you need to take a look at that, right? So this one we use in the class for that annoying problem that we were doing earlier. So the A B transpose is B transpose A transpose. You need to know this stuff. If you don't know this stuff, you cannot solve those equations. They're gonna be very difficult for you to solve. We talk about the zero matrices and upper triangular, lower triangular, the things that I went in class so many times. You can take a look. You see this notation I3 means that this is the matrix of size 3, or if you want to say it in another way, this is a 3 by 3 matrix, right? Yeah, so this stuff, I mean, you need to practice, right? There's no such a thing as I can do everything for you. You have to practice by yourself. Wow, I don't know who's making noise outside. Yeah, these properties, right? So make sure that you review this. This is not the only one that I post. I post another one here too. You can take a look at that. And here they show you how to compute. They talk about the Kramer's rule. All these concepts are here, the determinant, everything. Everything is here. So if you don't practice, I mean, even the Gauss-Jordan, they explain to you how to do it here, right? Reduced row echelon form. So it's explaining it here. You need to practice. You need to practice as much as you can. If you don't practice, then I don't know what to do. To be honest with you, I don't know. If you want to fail, like I said, the marking period 4, then that's fine. It's up to you, right? I cannot do more than this. I'm giving you all the resources that you need. I'm giving you my time. I'm giving you more than my time because I record myself every single night. And even if you think this is challenging, you need to practice. There's other things here. So you can take a look at that. So they explain to you why A transpose IJ is just a AJI, right? They explain to you, like they give you examples here how to do the transpose. Right now, I think the transpose is not a big deal, but you should know that it's the same things: matrix addition, subtraction, right? This is the identity of a 2 by 2. You should know how to do this. Commutative property: A plus B is the same as B plus A. Associative property is the same. A plus the 0 is 0 plus A. Uh, this is the property that I mentioned many times, so you need to practice this, right? A plus B transpose is A transpose plus B transpose. Scalar multiplication, right? So this number, -2, multiplies each element in the matrix. What else? Let's see, what is here? This is matrix multiplication. In other words, the dot product, right? So you can you can practice here, right? So this is what one, like row one, column one. So this is 1 times 0 is 0, and 6 times -1 is -6. So you can practice these things, right? 1 times -1 is -1, and 6 times 12 is 12, and -1 plus 12 it's 11. So you can practice. This is just the dot product. All these conceptual stuff you don't need to know. You just need to know how to apply it, right? So here they talk about the commutative property. With some, like, sometimes this might be true, like I said in class many times, but not in generally it's not true, right? So here you have more properties. This is the one that I always tell you you need to remember. A B transpose is B transpose A transpose. You need to know this stuff, right? If you don't know this stuff, then it's very difficult for you to be able to do these problems. You don't need to know everything, but the things that we went over in class, you should go over this and say, oh, okay, this one I need to know, or this one he do a lot in class. Especially the problems, when I solve the problems, you will realize, oh, this one, he uses it all the time. I'm not gonna use all these pages, right? Of course, but these are good to review. It's for your own benefit. It's not for me. So here they talk about the A inverse. Inverse, that's just the identity, right? You should know that by now. What happens when AB inverse, so that the order change, right? So that would be B inverse, A inverse. A transpose inverse is A inverse transpose is the same thing, right? You can assume that the identity, the inverse of the identity is just the identity, right? And let's see what else. So here they talk about how to find the inverse. This is the formula that I talked to you about many times. And that's pretty much it for these concepts, right? So let's do some examples so you can understand what's going on. Let me share this with my screen with you. Okay. So let's do some practice questions, right? So for example, if they're asking me if they're asking me number 1, I'm gonna do 5, okay? So ax plus b equals c. So how I'm supposed to solve this? The first thing I need to isolate is x, right? So I subtract negative b in both sides. You might say, oh, you did this in class, it's boring. Yeah, but I mean, I have to make sure that everybody, not just you, understand. So this is c minus b. That's what you did, right? And after that, you need to multiply by A inverse on the left side, right? On the left side to the left of the equation. And then I need to do the same here. On the right side, I need to multiply by to the left of this C minus B. So these things, they cancel. So you get X equals, well, not cancel. In reality, it's the identity times this X, right? But you know, the identity times this X is just X. So this is A inverse C minus B. And in this problem, they give you A, B, and C. So A is 1, 0, -1, 1. B equals 0, -1, -1, -1. And C equals 1, 1, 1, 1, right? So if you want to compute this stuff, first of all, you need to find what C minus B, right? So that's straightforward. So C minus B, and that will equal this new matrix, right? Let's assume that this is C minus B is 1, 1, 1, 1, and then this B is what is this thing? Let's see, what is B? It's 0, -1, -1, -1. So you can do these things, right? So this is equal to C minus B equals 1, 2, 2, and this is what is this thing equal to? 2. Yeah. So this is 1, 2, 2, and 2, right? So that's what you get when you're doing this computation, right? So this is 1, 2, 2, and 2. And A inverse, we need to compute it, right? That's not big deal because A inverse should be, for a 2 by 2, is just 1 over the determinant of A, right? And this is the adjoint of A transpose, right? So if we do that, the determinant of matrix A is just 1, it's just 1, right? Because it's 1 minus 0, so it's just 1. So I don't need to worry about this. So this is 1 over 1 is just 1. And the adjoint matrix of A, when it's a 2 by 2, I don't need to worry too much, right? That's not difficult to do. So it's basically changing the position. Remember, this is what? A equals A, B, C, D. And the adjoint of A, right? The adjoint of A in a 2 by 2, just in a 2 by 2, because if it was a 3 by 3, we will have to do something else, right? So this is D, A, negative B, negative C. So here I have 1, 1, yeah, and then this is 0, and this is 1, right? So that will change the order. So if you multiply that 1 times that matrix times the adjoint of that, you get the same thing, right? You should get the same thing. And yeah, so you need to move, this is A inverse. So this is 1, 0, 1, 1, and then you need to multiply this by this guy, this thing right here. So if you multiply that, you should get your answer, right? So this is the dot product, and this is what, 1, and you have 2, and then on the bottom you have 3, and then you should get here 4. So this is supposed to be the answer for this problem. Okay, so this is answer for this problem. So 1, 2, 3, 4. Right? We have to use the dot product, and we need to compute this thing. I hope this makes sense. It's not too difficult, this problem. It's just, you know, you need to practice and do the computation, and then that's fine, right? Next number, 2. Okay, so 2, I have AX B equals BA, and they give me the matrix A is 1, 0, 0, negative 1, and B equals 0, 1, 1, negative 6. Okay, so what I need to do here is what? I need to solve for X. So what I'm gonna do, instead of doing two things instead of doing one thing and then another thing, I will do two things at the same time. So I will multiply the left side by A inverse, and I will multiply the right side by B inverse. So you will get this, right? So this is the identity, everything cancels out. So you get X equals A inverse times B times A times B inverse, right? That's what you get when you're doing this computation. What's next is you need to do the math, right? So here you need to find the A inverse. Again, this is not difficult, right? Because we have the 2 by 2. So if we do the adjoint, or the adjoint formula, 1 over the determinant of A times the adjoint of A transpose, right? So the determinant here is what? The determinant here is, let's see, 81. The adjoint here is just changing the position of these things, right? So for a 2 by 2, so this is negative 1, 1, and the signs they change, but in this case, since they're 0, nothing special happens, right? So A inverse equals negative 1 times negative 1, 0, 0, 1. And you basically do the scalar multiplication, right? You multiply the negative 1 value to each element in the matrix. So you get 1, 0, 0, negative 1. So that's your A inverse. So you need to put that in the equation, right? So you get that. So let me copy this. So you get that thing. And then B is this, right? You can just copy this. And let me make it smaller so everything fits. And then we need to multiply by A, right? Which is here. So that's not a big deal. So you paste it basically here, and then you need to multiply that by B inverse. We don't have that. We don't have that, unfortunately. So we have to do, again, that computation, right? So this is B inverse. So B inverse is 1 over the determinant of B times the adjoint of B transpose. Yes? So let me, I don't have enough room to do all these things. Okay, so let me make small this thing here somewhere, put it somewhere else. here. And let me bring this here. Okay. So B inverse is 1 over the determinant of B. What is the determinant of B? Well, that's just 0 minus 1. So it's just -1. What's the adjoint matrix of B? So the adjoint matrix is just switching the positions, right? So this is -6, 0, -1, -1. So you need to distribute that, right? So this is -1 times -6, -1, -1, 0, and then B inverse should be equal to what? You have to do the scalar multiplication here. So this is 6, 1, 1, 0. So that's this value of this thing, right? So copy, paste. So this is what you have so far. And let's continue doing this thing. So now at this point, I would not do this by hand. I will use my calculator because that's the easy way to do this. I'm not going to show you how to do that because I assume that by now you should know how to do that. If you don't know how to do that, just check the video that I show you how to do all that stuff, right? So let's do the matrix multiplication here. 2 by 2, 1, 0, 0, -1. So first one, so matrix, edit, second matrix, this is also 2 by 2. And then we get 0, 1, 1, -6. And then for the C, it's a 2 by 2. I get 1, 0, 0, -1. And then for 4, you get 2 by 2, and you get 6, 1, 1, 0. And then you do the computation. That's it, right? So this is quit second matrix A times second matrix B times second matrix C times second matrix D. And then you compute that and you should get this answer, right? So this is your answer. X equals -1, 0, -12, -1. So that's the answer for this problem. Okay, that's how you do that. This is the answer. Okay, next number, 3. So we don't stay here forever in this video. So 3 is, what is 3? Let's see, what is 3? So we have XA plus C equals XB. Okay, so I need to solve for X basically, right? So I need to put X's together, and then the C should be on the other side by itself. So now we can, let's see what we can do. So here we can do X, and this is A minus B, right? So I'm doing this to the left, actually to the right, right? I factor to the right. So this is -C. So if I do the inverse, right, I have to do it to the right as well. So this is A minus B. So I will have to do inverse to the right. So let me show you what I mean by inverse to the right. So I have to do here A minus B inverse. So I have to do the same thing on the right side of the equation to the right. A minus B, -1. So this cancels out. You get X equals -C, A minus B inverse. Okay, so now what we need to do is find out what those matrices are that I forgot to put them in the beginning. Okay, so the matrix is A equals 1, 2, 1, 1, 2, 9, 10, -3, and 5. So B equals what? B is 2, 2, 0, 1, 3, 9, and then we have 10, -3, 4, and matrix C is 1, 3, -6, 0, 1, 0. And notice that these A and B are square matrices and the C is a rectangular matrix, right? You have to know that. Okay, so at this point, the only thing I need to do is just compute, right? Compute A minus B first. So that's gotta take some time, right? A minus B. You can use a calculator, or you can do that computation, you know. It's up to you, right? How you want to do it. So A is 1, 2, 1, 1, 2, 9, 10, negative 3, 5. And then we have B is 2, 2, 0, 1, 3, 9. And then we have 10, negative 3, and 4. So this is A minus B. And yeah, so I need to do the subtraction, right? So this is not big deal. The subtraction is very easy thing to do. So this is my, actually, I should move this thing around, right? So I should move this thing here. And this is 1. 1 minus 2 is negative 1. 2 minus 2 is 0. 1 minus 1 is 1. And then you have 1 minus 1 is 0. 2 minus 3 is negative 1. 9 minus 9 is 0. 10 minus 10 is 0. Negative 3 plus 3 is 0. And 5 minus 4 is 1. So that's A minus B. Now you need to find the inverse of this, right? So the inverse of this, it might take some time, right? I'm gonna just do it for practice. I'm gonna do the Gaussian elimination to do this thing, right? Just for practice. So this is negative 1, 0, 1, 0, negative 1, 1, 0, right? And then we have 0, 0, 1. And if I do the augmented matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, what I notice is that I can get rid of, I can divide everything by negative 1, right? So I'm doing row 1 divided by or multiplied by negative 1 to get new row 1. So if you do that, this is going to be plus, this is going to be minus, this is going to be minus. And then you can do the same thing for row 2, right? You can do negative 1, row 2, give you new row 2. So if you do that, you get 1 here, right? And then you get negative 1 here. So let's do the computation. So we can do the same thing. Let me erase this. Let me copy. Yeah. So let's see what we can do. So what's gonna change? Let's see what we can get rid of so we can solve this problem, right? Let's see what we can multiply by or do this computation. Okay. Okay, I'm gonna do row 3 plus row 1 to get new row 1, okay? So that's not big deal. So if I do that, so row 1 is gonna change. So do it. 0 plus 1 is 1, 0 plus 0 is 0, 1 and 81 gives you 0, 0 and 81 gives you 81, 0 and 0 gives you 0, 1 and 0 gives you 1. So I get it. I got the inverse already. So this is the inverse here. So the inverse of A minus B, this is A minus B. So that means I don't need this calculation anymore. We can delete this. This is A minus B, so we can put it here. And A minus B inverse is this thing here, right? So let's put this in. Let me copy this. They're smaller, then you can put this in this. Okay. 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 So this is the A minus B inverse, right? So let's change the color. Let's put that in this color. Same thing. Okay. So what's next? What's next is we need to multiply negative 1 times C, right? So X times, I'm sorry, negative 1 times C. So the only thing is going to change is that sign, right? Negative 1, negative 3, 6, 0, negative 1, and 0. And then I need to multiply by the thing that I just found, right? My inverse, this one right here. Copy. Now, you need to verify if the dimensions they work. I mean, they match, right? So this is what? This is a 2 by 3, 2 rows, 3 columns, and this is what? 3 by 3. So what's happening? So you have the dimensions they match, so you're gonna get as an answer 2 by 3. So you know what kind of matrix you're gonna get. So you need to compute that. You need to solve that, right? So X equals, do the dot product, right? So you get, for the first one, you get 1, right? And then then you get a bunch of zeros. So for the second one, you get 3. And then for that row 1, column 3, you get, let's see, -1 and 6. That should be 5. Then you do the dot product one more time. So everything seems like it's going to be 0 here. And then everything is going to be 1 here. And then for the last one is 0. So this is your final answer. Make it smaller a little bit. This is the answer. Okay, this is the answer of this problem number 2 or 3, whatever. Okay, that's how you do it. Okay, so I did the Gaussian elimination. I did the adjoint over 2x2 matrix. So you're reviewing while you're watching this. So that was 3. Now we have to do 4, right? I mean, let's do another one. So I have AXA, not XA, transpose, equals square root of 5, square root of 5 times A. Okay. So at this point, we can do too many things, right? I'm gonna do A inverse here. I'm gonna do A inverse here, right? And what else can I do? I can do A transpose. Let's put A transpose on the left. I'm sorry, on the right, and let's do A transpose here. So you know here everything. Actually, this is not A transpose. My bad. Here we need to do. Let me move this around. Okay. Here I need to do A inverse transpose, right? The transpose of that. Yeah. So that will cancel out. So these things, they cancel everything. So this is X equals, and I need to do A inverse transpose here, right? A inverse transpose. Okay. So if I think about this, here, these two, you have A, and this is scalar, doesn't affect too much. Okay. This one is just multiplying the matrix by the square root of 5. But these two, if you move the 5 to the left or to the right, because I said that 5 doesn't bother too much. If you do that, you're gonna get the inverse, right? So basically, I'm sorry, not the inverse, you're gonna get the identity. Remember, A inverse times A equals the identity, right? But the identity here should be, I need to give you the matrix first. A equals 1, 1, 1, 0, negative 1, negative 1, negative 1, 0, 1. And as you can see here, yeah, as you can see here, this thing is a 3 by 3. So when you doing the inverse or the transpose of this matrix, it doesn't matter. It doesn't really matter what it is. What I'm trying to say is that this A inverse times A is going to give you a 3 by 3 identity. So you can say this is I3, right? Times the square root of 5 if you want. You can say that square root of 5, but you can put it here or there. It doesn't make a difference, that square root of 5. So let's do that. Square root of 5 times I3, which is the identity of a 3 by 3 matrix. And you need to find A inverse transpose, right? Or A transpose A inverse. It's the same thing. So how can we calculate this? Well, we need to first calculate the inverse of this matrix, right? So that's gonna take some time, right? We need to put that in the calculator. So if we put that in the calculator, let me edit that, and this is gonna be a 3 by 3, and this is 1, 1, 1, 0, negative 1, negative 1, and then we got negative 1, 0, 1, and then we do matrix, and then we just quit, and then second matrix, 8, and we do the inverse of that, and I do the inverse, I get 1, 1, 0, negative 1, negative 2, negative 1, and I get 1, 1, 1. But remember, I have to do A inverse and the transpose of that, right? So A inverse transpose. So the transpose is what? Just change the rows with the columns, right? So this is 1, negative 1, 1, negative 1, 1, 1, negative 2, 1, 0, negative 1, 1. Yes? So that's the transpose of that. Now, yeah, so this is what? X equals root 5. So this is what? 1, 0, 0, 0, 1, 0, 0, 0, 1 times, right? This thing that I just found. Let's do that. Yeah. So if we do that, at this point, doesn't matter. I told you that 5 doesn't affect too much. So we can use the dot product for the I3, which is the identity matrix of a 3 by 3 and the A inverse transpose, right? So I'm going to keep this until the end. So let's do the dot product. So we have 1 here. Then we have negative 1, row 1, column 1, row 1, column 2, row 1, column 3, and then row 2, column 1. You get this. Row 2, column 2 is negative 2. And then you do row 2, column 3, you get 1. The same thing applies for the last one. Well, the last one is going to be 0, right? Yeah, it's 0. And then we get negative 1. Actually, no, we don't. Okay, this one is 0. Then for the last one is negative 1. And then here we have 1, right? Just use the dot product and you will realize what it is. So now what you need to do is just multiply that scalar multiplication, right? You need to multiply that square root of 5 times every element in the matrix, right? So let me do that. Okay, so these disappear, right? Because we need just the numbers. So this is square root of 5, negative square root of 5, square root of 5, square root of 5, negative 2 square root of 5, square root of 5, 0, negative square root of 5, square root of 5. So that should be the answer for this problem. And indeed, that's the answer, right? So this is the answer for this problem. Okay, so that's number, whatever number that was, 4. Okay, I hope you understand. So let's continue. 5. We'll do one more and that's it. Okay, ax minus x b. You have to be careful with this problem, right? So for x and a, they give me a and b. So a is 2, 3, 2, 1, 2, 1, 0, 3, 2. That's a. And b, they gave me 1, 0, negative 1, 0, 0, 0. And this is 1, 0, negative 1, right? So first I need to solve the equation. So this is what? Here you have to be a little careful. Here you need to sort of, it's kind of you have to factor, right? So x times that would be a minus, this is a common problem that everybody will do. A lot of people do this. A minus 1, and intuitively it kind of makes sense because you say, oh, a times x is ax, and x negative 1 times x is just negative x, but that's wrong. Remember, you're not doing you cannot subtract a matrix. Like for example, if a was, let's say, like a is what, 2 3 2 1 2 1 0 3 1 0 3 2. Can you subtract that from 1? Impossible. You cannot subtract a matrix from just a number. You cannot do that. That's impossible, right? Because this would be what, 1 row 1 column, and this would be 3 by 3. That this match, the dimensions match? No, you cannot do that. So that means that this is wrong. So what should I put for 1? The identity. The identity that work out, right? That's the identity is a matrix. So be careful when you're doing this computation, right? So this is B, and because I multiply or I factor it out, whatever you want to call it. If I factor it to the left, I have to do the same thing here in the right side of the equation. So this is a minus I times b, and I need to solve for Actually, I need to multiply by a minus I here, inverse, right? So this, anyways, on the right side of the equation, I need to multiply to the left, right? So these things, they cancel. So I get x equals a minus I inverse times b. So I need to calculate, I need to subtract a minus the identity of a 3 by 3, right? Because this is a 3 by 3 and the dimensions, they might match. So this is I3 actually, right? If you want to be more precise. So this is I3. Okay, so this is a, okay, so we have a minus I3, 2, 3, 2, 1, 2, 1, 0, 3, 2, minus 1, 0, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so let's do the computation, right? Okay, so what is this equal to? So we just subtract, right? So this is 2 minus 1 is 1, 3, 2, then 1, then 1, then 1, then 0, then 3, then 1. So this is a minus I3, or a minus the identity of us of size 3 by 3. Now I need to find the inverse, right? So this is, we don't need to do this, or we don't need this calculation anymore. So this guy is this guy, right? So we need to do the inverse of that. We need to do the inverse of that. So a minus I3 inverse. So if we do that by hand, it's going to take some time, right? So we have to use a calculator to make it faster and edit. So this is also a 3 by 3. Numbers are 1, 3, 2, 1, 1, 1, and then we have 0, 3, 1. We need to calculate the inverse of that. Second matrix, 3 by 3 to a negative 1. And we get some number, right? So we get negative 2, 3, not number, one matrix actually. Negative 1, 1, 1, 3, negative 3, negative 2. So this is the matrix A minus I3 inverse, right? So we just basically copy and paste, right? At this point, copy, paste. So this is that. And what's B? Well, B, you have it in here. Copy, paste. So at this point, you can do matrix multiplication, whatever, the calculator, whatever you like, right? At this point, there's no right or wrong method. So I got an inverse. I just need to find out what's, I need to multiply that by the second thing, the second matrix. So I'm gonna try to do that 3 times 3. And I got 1, 0, negative 1, 0, 0, 0. And then I got 1, 0, negative 1. Let me double check if I type the numbers right. So that's good. I need to do quit, and then I do times second matrix B, and I should get my answer. So my answer should be negative 1, 0, 1, 0, 0, 0, 1, 0, negative 1. So that's the answer for this problem. Yeah. So as you can see, it's not difficult, right? It's very easy thing to do. Let's do one more. Yeah, this is the last one for this. And then I will do the annoying one that you have trouble with in the class, I think. Okay. So number 6. Number 6 is asking you AX times B, or AXB, right, equals C. And at this point, you should know what to do, right? I mean, I need to do what? I need to multiply to the left times A inverse, and also here. And then I need to multiply to the right here by B inverse, and I need to do the same thing here. So all these things, they go away. So this is X equals A inverse C B inverse, right? So we need to compute this, right? And in the problem they give 1, 2, 2, 3. That's A. Then they give B equals 1, 0, 1, 0, 1, 81, 0, 0, 1. Please practice these same examples I'm doing right now in the video. Practice when you at home after you watch the video, or you pause the video and you try by yourself, do whatever you feel works out for you. Okay, I'm just giving you the solutions and the steps so you can have an idea how to do it. So now at this point is just computing this thing, but I have two issues. I don't have the A inverse and I don't have B inverse. Okay, I need to find them. So A inverse of a 2 by 2, right? You can put in the calculator at this point. I'm not gonna do that by hand. So edit. So this is a 2 by 2. We have 1, 2, 2, 3. Okay, quit second matrix A to the -1, and I get my inverse, right? So my inverse for this problem is -3, 2, 2, -1. So that's A inverse. So now I need to find B inverse, right? So B inverse, let's find it. So B, edit B, it's a 3 by 3. So 1, 0, 1, then 0, 1, -1, and I have 0, 0, 1. Then we do matrix B to the -1. So I did 1, 0, -1, 0, 1, 1, 0, 0, 1. So I have A inverse, I have B inverse, and I have C. I have everything that I need. So let's do the computation now. So X equals to A inverse. So that's right here. And C is right here. Well, I shouldn't put C. Just need to put this guy. So this thing here, we make this smaller. So because we don't put A inverse, I don't need that. So yeah, so this thing goes here, this thing goes here. Yeah, this thing goes here. And then I need B inverse, right? So I have A inverse, C, I have B inverse. So I need to put B inverse here too. So B inverse, I don't know why people make that all the time noise. Okay, copy and then paste. Okay, let's see. Yeah, so this is what we have so far. Okay, so now we have to do the computation, right? You have to check the dimensions first, right? So this is a 2 by 2 and this is a 2 by 3. Can you do that? Yes, because the dimensions, they match. So you, as a result, get a 2 by 3. Now, with this one right here, you have a 3 by 3. Do the dimensions match? Yes, right? You have a 3 with 3 and 2 by 2. So you get a 2 by 3, right? So 2 by 3 times 3 by 3, you get a 2 by 3, right? That's how you can find out what it is. So you know what result you will get, right? You can predict what's the outcome of these three matrices. Okay, so let's compute. Now we can put in all these things in the calculator, right? So let's do that. So, okay, matrix. Okay, this one. Edit. Let me see what do I have here. So I need to edit this. So -3, 2, 2, -1. So I'm done with that. Matrix. I need to edit this B, right? The B is 2 by 3. And I got 5, 12, -2, 8, 18, -2. And then let's do the last one. Matrix, edit. So this is going to be a 3 by 3. So this is 1, 0, -1, 0, 1, 1, 0, 0, 1. Okay, so I have the three matrices. So now I can do the computation. So A times B times C, right? And I should get my answer. So as a result, as expected, I get a 2 by 3. So this is 1, 0, 1, 2, 6, 2. Yeah, that's the answer. Okay, so I did 6 problems, right? I did 6 problems. Now I'm gonna do the annoying one, right? The one that was that we were doing in class, the tough one, whatever you want to call it. Reality is not tough though. What is that thing? I cannot find that problem. The morning I couldn't find it too. What is that? No, not this one. Remember, I leave it incomplete because I didn't have time to do it. Let's see, what is it? Oh, here it is. Here it is. Okay, let's do that. Let me copy. Good, so, okay, let's do that. Okay, let's do that here. Let me make it smaller. And you can see that. Okay, so let's do this part first, right? Like I was doing in the morning. So we have X, C inverse transpose. So this is going to be C inverse transpose, right? And then you have X transpose. Remember the order reverse, right? When you're doing the transpose. Those are the properties that you need to study, right? From the thing that when this video starts, I show you where those papers are. Okay, so now you need to do what? So you have B transpose, right? Because -1, you can think about to the B to the -1 to the power of -1 will cancel out, basically. That will give you a +1. And then you have the transpose, so that's going to be just B transpose. And D inverse is just going to give you D. Now this part. So this is D transpose X, right? Because transpose give you the same matrix X. Now you have C transpose to the -1. And then you have C transpose, A transpose, that's just A, and minus D transpose X. So let's see what's gonna happen here. So we can cancel these things out. This guy goes away. So we have negative C transpose, or negative C times, -1 times C transpose inverse. And then we have C transpose A, right? Okay, so what's next? On the left side, we have C inverse transposed, X transposed. So here I have subtraction, so I can put that in the other side, right? So you can think about this way. So you can add B transpose D, and you add B transpose D here. So you can do like when you're solving an equation, basically. That's funny. C inverse T, X transpose equals, we have negative C transpose -1, or to the power of -1. I'm sorry if I'm using the wrong vocabulary. A plus B transpose D, right? So here, let's see what's happening here. If you notice here, we have the inverse of this we have C transpose inverse. So those two, they can cancel, right? So those two, they cancel. These two, they cancel. So you have negative A, B transpose. Remember, this negative A is multiplying this thing, right? Negative A, B transpose D. Okay. So if we want to cancel this C inverse transpose, we can multiply by C transpose. So those two, and if I multiply to the left, I have to multiply by the left here, right? That's what's happening here. Let me go back one step, so I don't want to confuse you. Let me go back one step here. So I said that those two, they will cancel, right? Let's do this computation first here. So we do these two, they cancel. So you have X transpose now on the left side, and then we have C transpose that is multiplying all these things, right? Negative C transpose -1 C transpose A plus B transpose D, right? And these, they cancel. These two, they cancel. So basically you have negative A plus B transpose times D, right? Times DC transpose, and this is equal to X transpose. Yeah. Okay. So now how can we get rid of all this stuff? Well, what we need to do is we can transpose the t, right? Because if we transpose the transpose, we get x back. So this is x equals, well, whatever that is, right? So we have these things here. So we have to do in reverse now, right? We have to do this one first. Actually, I can take this out. I don't need this thing anymore. Yeah, I don't need this anymore. So you have this expression first. So you have B transpose, B transpose, transpose, it cancels out. And then you have minus A transpose, and then you have plus C transpose, which is C, right? So that's the answer for this problem. Let me see if I get the same thing when I did it by myself, because sometimes when I'm doing these things, I might get confused. Not because I don't know, it's just because of the computation might be annoying. What is this thing? Let's see what I get. If not, I did it already. Let's see what I did here. So let's review. Basically, I did the same thing. Here I multiply by C transpose. If you're confused what I'm doing, this step is just the same as the previous one. So copy, paste. So that's what's happening here. Yeah, I add these things in both sides. I cancel things here. I get negative A. I see I have a little different though. I got a feeling that I have a little different here. Let's double check. Let's see. So this part is okay. Oh, I see what I did. I see what I did. This one, okay. So let's check this stuff. So here, yeah, here we have C. Yeah, we add this in both sides, and we have C inverse transpose X transpose, and this is equal to, this cancels out, like I said before. And this is negative A plus B transpose. Yeah, that should be done this way. Yeah. And then after that, what I have to do, I need to multiply by C transpose. I'm sorry about that. C transpose, and then you need to multiply by C transpose on the left side. Okay. So this cancels out, and you get X transpose, because they cancel, right? These two, they cancel. And you get X transpose equals C transpose negative A plus B transpose D. If you want, you can distribute it. It's not a requirement. So yeah, so you can get C transpose B transpose D, and now you can transpose it, everything, right? So transpose of all this stuff. So this is X equals, let's do the computation, right? Okay, so if we start by this one, yeah, we get C negative. Transpose is just it goes back to C, and then this is A transpose, and then this is what is this thing? A transpose B and C. That's it. That's the answer. Now it's okay. So you have to be careful, right, when you're doing this computation, because if you do one mistake, everything is wrong. Now we can plug these things here, right, and do that matrix multiplication. Let's see if you want me to do it. Let's do it. So this is negative C. I don't know what C here. Let me see what C. C is this guy right here. So copy. So this is the easy part. This is no longer difficult at this point, right? This is the easy part. Okay. So this is this. Okay. And what happened this thing? Okay. So I want to go away. Okay, so that's negative C, A transpose. I don't have A transpose. I have to do the transpose of that. Okay, let me copy that. So this is A, copy. Okay, so this is A, and I need to do the transpose of that. This is A. So A transpose is just changing the rows to columns, right? So this is going to be 1, 2, negative 1, 2, 0, negative 2. So you get, before it was a 2 by 3, now it's a 3 by 2, right? Once you do the transpose. So let's do that, copy. So that's negative C times A transpose. And I need to find out what's D transpose. I don't think they gave us D transpose. There's no D transpose here. Probably they give you another matrix here. Okay, so since I lose that matrix, I don't know what it is. I'm not gonna do that computation because I don't have that. So you can do that by yourself. You know how to do that. It's just multiplying and adding and this kind of stuff. But the main thing is you need to practice this one, right? This one is a little tricky. Okay, be careful when you're doing the computation. Be careful. And let's do a new one that you don't know how to do it, or I didn't do that yet. So this will be like 7, right? This is 7. And now let's do 8. Let me see if you can do the, I mean, let's see if you can understand these kind of problems. Let's see if I have that somewhere here. Where is that thing? Let's see if I have that problem here somewhere. Yeah, here it is. So they might say to you things like this. Solve the matrix equation, right? So, for example, they might give you this. 2x plus y equals A, and 4x minus 3y equals B, given that A equals negative 1, A 7, and B, I'm sorry, I'm still in matrix A, negative 3, 6, 12, and B equals, let's say, 15, negative 4, negative 21, what else? Negative 11, 12, 14. Okay, so now we need to solve this thing like algebra, like we always do, right? So I have, let me copy this. I have this situation. So I'm gonna multiply by negative 2 to get rid of x, right? Like I do system of equations in 2 variables, right? So this is negative 4x minus 2y equals negative 2a, and then I have 4x. I can just copy it. I have to do that. Okay. Okay. So that means that this goes away. So I have negative 5y. Let me put that here too. Save space. Negative 5y equals, well, b minus 2a, right? And then I need to multiply or divide. In this case, I can divide that by, because I'm solving for a variable, right? This is not matrix, right? We need to solve what, we need to find out what's the value of y, right? So here you can do b minus a times negative 1/5. So that's a scalar multiplication. So this is negative 1 over 5. So this goes away, right? If you multiply this by negative 1 over 5, this will cancel with this, and negative makes a positive. So that's just y by itself. And this is negative 1 over 5 b minus 2a. So now you need to plug that here, and you need to do that multiplication, right? Negative 1, well, yeah, b minus 2a, right? So we need to find out what's 2 times a, and we subtract b from that. So y equals negative 1/5. So we can do like this. What's b? So b is this guy right here, right? Okay, so this is b, and -2, let's put it here, -2 times a. So we can just do that simultaneously, right? So we can do 2 times a. So 2 times a. So this is 2, -2, 16, 14. This is 6, -6, 12, and 24. So now we can do the subtraction of these two, right? So y equals -1/5 times, okay, we need to compute this. So this is 15, right? Because a negative makes a positive. So -4, -20, right? Yeah, -20. And then we got -21 minus 14, that should be -35. And then we have here negative, actually that's not, this is what, 5? Yeah, that's 5, right? -5, -5. And then we have 0. And then we have 14 minus 24, that's -10. Now you need to distribute this thing, right? So y equals, so this is going to be -3, then this is going to be 4, then this is going to be 7, then this is going to be 1, this is going to be 0, this is going to be 2. Right? So that's the value of y, that thing. Now I need to find x because I'm not done yet, right? I need to find x. So let's find x. So I'm going to plug it, I don't know, anywhere, doesn't matter. I think it looks simpler in the first equation. So let's do that. 2x plus y. Actually, we can do, yeah, 2x plus y equals a. So that means that x will be what? 2x equals a minus y, right? And then we can multiply that by 1/2. So 1/2 a minus y will give me my solution, right? For x. So x is 1/2 a minus y. So what's a? A is here, right? So here, a minus y. What's y? This thing right here. Make it smaller. So now you need to just do the subtraction and then multiply by the scalar multiplication, right? So this thing, it come out to be, well, this is 2, right? And then we have 4, and then we have 0, and then we have -4, then we have 6, and then we have 10. And then if you multiply that by 1/2, you get 1, 2, 0, then -2, 3, and 5. And that should be your matrix X. And that's the right answer. This is the right answer for Y, and this is the right answer for X. So I solved the system of equations of the matrices. Well, that's the system of matrix equations, right? So this is not new for you. It's just that we just need to apply the concepts that we just learned in this class, right? I hope that you understand these things. I want you to go over these problems that I'm doing here. Okay? I want you to go over one by one. Try to do them. If you don't do them, you will not get it. You have to practice. I told you, you have to practice. Okay? If there's no more, I mean, nobody's gonna ask me a question. Okay, have a good night. I'll see you tomorrow in class. Bye.